Ladies and gentlemen, welcome to our presentation on cardiac disease prediction using artificial intelligence. On behalf of myself, Hamda Al Ali, and my colleagues Ruqayya Al Hamadi and Marwa Al Hosani, we are going to start by discussing the problem statement, medical background, proposed design, technical background, dataset, project implementation, results, application, local web service, and the final product. This is the statement of the problem we want to address in this project. We will implement a system to predict heart disease based on symptoms supplied by the user. The system will use machine learning artificial intelligence to classify the symptoms and identify a specific heart issue. Information will be available to medical professionals over a local web service. Let us go through the medical background of CHD. I would like to give you an overview of coronary heart disease. Coronary heart disease occurs when the major blood vessels that feed the heart with blood and oxygen become damaged or diseased. An essential factor in preventing CHD is an efficient health check. With machine learning algorithms, we can decrease time and minimize the cost, thereby making the diagnosis problem easier for CHD patients. As we are going to build a prototype model, we choose CHD as a specific disease that our model will predict beside the heart disease in general, because some of the symptoms that were in our dataset are CHD symptoms. Moving on to the proposed design. As you can see, the main object of this project is to build a prototype model to predict heart disease using artificial intelligence. Once a user successfully opens the system, then the user has to insert data of symptoms. The predictive model predicts the disease of a person and gives output depending on the symptoms entered by the user. If the result were negative, the user will receive "you have no heart disease." But if the result were positive, "you have heart disease" or "you have CHD." If the result were positive, it will send it directly to the hospital and an ambulance will be sent if needed by the push button "please call the ambulance." Now, turning to the technical background. Identifying heart disease in emergency clinics is a standard procedure. Machine learning must be established that can handle large amounts of data quickly and accurately. To diagnose cardiac disease, several dataset processes including characterization and diagnosis may be used. Classification algorithms use input data to predict and categorize it. This gives the best grouping model for an expectation of heart disease results. My colleague Ruqayya now will start to explain the machine learning.
We train the classification algorithm using the input dataset. When we train machine learning, we will have two methods, supervised and unsupervised. Supervised learning is a machine learning that uses labeled dataset. Unsupervised, it uses unlabeled dataset. Due to the clear difference between them, we figure out that we need a supervised learning algorithm to do this project. In the next part, we will talk about choosing 5 machine learning algorithms. We have chosen 5 classifiers: k-nearest neighbor, support vector machine, decision tree, artificial neural network, and naive Bayes. Based on our literature review, they have applied different algorithm and dataset techniques for diagnose and achieve different probabilities for different methods. Now we will have to explain 5 selected algorithms. First, k-nearest neighbor is used to classify the data point based on the neighbor are classified. Linear support vector machine is used a linearly separable data, which means the dataset can be classified into 2 classes by using single straight line. Third, decision tree. The goal of this algorithm is to create a model that predicts the value of the target variable. In addition, missing value in the data has no significant impact on decision tree. Fourth, naive Bayes algorithm classifier assumes that the presence of particular feature in the class is unrelated to the presence of any other features. 5. Artificial neural network is a process that mimics the way the human brain operates. So after we review the 5 algorithms, let's talk about the different datasets we are used. In our project, we used 2 different datasets to train the supervised machine learning algorithm. The first dataset is the Cleveland heart disease dataset, and the second dataset, FHS dataset. The reason for using 2 datasets is that each one has different unique features and attributes. This will help to obtain high percentage of prediction. I would like to make more detailed recommendation regarding implementation details. In our project, we have changed some minor details that we are demonstrated that did not affect the kernel of the project. The first modification we did that we preferred to use the Python instead of MATLAB. Python code is more compact and readable than MATLAB code. The second modification is that we switched the local and with the web server with the local machine. As we are implementing a prototype, we found out it's better to start with the local machine than the cloud. The third modification is that we have cancelled the artificial neural network classifier. So we start working on the 4 classifier algorithm by trying each algorithm into 2 datasets. After finishing these steps, the best classifier and dataset we are choosing based on their accuracy. So our next important element is Python. We have developed all Python code using Spider and Anaconda compiler. Used Python package, scikit-learn, NumPy, Pandas. Scikit-learn is a machine learning package that includes a lot of machine learning algorithms. NumPy is used to read data in NumPy arrays and for the manipulation purpose. Pandas used to read and write different files. So now we will turn to the training and testing slide. We randomly split our dataset into two parts. The first part uses a training dataset with a size 80%, and the testing part have a size 20%. The goal of the training is to make a final prediction correctly as often as possible, and there is no optimal split percentage. I would like to move now to the next part of our presentation, which is talk about the result. In the next 5 slides, we use K-fold for training and testing two datasets 10 times for all modules to have the best average accuracy. Furthermore, in all modules, we imported from the scikit-learn package. Now, I would like to hand it over to my colleague Marwa Hosseini to discuss the result of the fourth algorithm.
The k-nearest neighbor algorithm is used to implement it by k-fold detection, which means 10 runs, and also we try using k equal to 3. We found that a larger k value means smoother curves of separation, resulting in less complex models. By using the k-fold detection, the first dataset, which is the CliffClan dataset, gave us 70%, and the other dataset, which is FH's dataset, gave us 85%. And for k equal to 3, we used only CliffClan dataset, and it gave us 70%. Moving on to our next algorithm, which is linear supported vector machine. The first dataset, which is a CliffClan dataset, gives us 83.2%, and the other dataset, FH's dataset, gives us 83.6%. The next algorithm, which is naive-Bayes algorithm, the first dataset, CliffClan dataset, gives us 83.9%, and the other dataset, FH's dataset, gives us 84.2%. The last algorithm, decision tree algorithm, the first dataset, CliffClan dataset, gave us 88%, and FH's dataset gave us 76%. We have chosen to work with decision tree and the CliffClan dataset as they achieve the higher accuracy average out of k-fold detections. I would like now to illustrate the problem faced by the result. We faced a major problem during the implementation of decision tree that can give only two binary outputs, either 0 or 1. After deep search and experimentations, we switched to naive Bayes and CliffClan dataset as everything was set and built for a CliffClan dataset attributes. Using naive Bayes, we can get the percentage of zeros and 1. If the output is 1, that means there must be a heart disease. If the output percentage from 75% until 100% zeros, that means there is no heart disease. If the output is between 50% until 75% zeros, that means there might have a heart disease. These percentage values based on a literature review and by asking specialist cardiologists about the outcomes. The procedure we worked with wasn't efficient and correct. About 75% the output values was wrong due to lack of medical knowledge. Now I will cover the mobile application part. The mobile application will be the main interface between the user and our system. We have created a mobile application using Android Studio, which is a free computer software that can be used to create and develop mobile applications. At the beginning, the patient will use the mobile application. It will ask him to insert the data of symptoms. After that, it will send these data to the machine learning. When the calculation ends, the result will be sending back to the application so that the patient knows if he has a cardiac disease or not. Moving on to our next area of interest, which is the flowchart of the mobile application. The following flowchart illustrates the mobile application screens. The first screen is the sign-in page, which allows the user to enter his email and password to access the application. The second page is the sign-up page, which is responsible for creating the user account by entering his information. The third page is the sidebar that works as the menu of the mobile application. By using this sidebar, user can decide which screen he needs. The fourth page is responsible for collecting the user's symptoms. The user will enter their symptoms manually as shown in the boxes. The fifth page, which is the last page, is showing the machine learning output for the user, followed by a medical comments for each situation. After we had covered the interface flow chart, let's move on to our next slide, which is local web servers. The main purpose of the local web service is to connect the mobile application with the machine learning files. It works as the link between both of them. We create the web service software using Visual Studio.NET as it's a computer programming language developed by Microsoft. We use the ready codes. The web service revives the entered symptoms from the mobile application and then send it to be processed using the machine learning Python code. Then, after receiving the output result, it returns back to the mobile application as well as save the symptoms entered and their results in the local datasets. Now, I will leave you with a video for our final product. Here we reach the end of our presentation. Thank you for your listening.